What's up guys, welcome back. Today we're going to be doing the chain rule. We'll do a bunch of different examples to see how you can apply them. So let's get into it. Alright, so this is the first question, y is equal to x squared plus 1, all the power of 5. Now when you do the chain rule, what you're doing is you're bringing this power down to the front, like so. The power gets subtracted by 1, so 5 turns into 4. And you need to multiply it by the derivative of the inside, hence like the kind of chaining action. So the derivative of x squared is 2x, and the derivative of 1 is 0, so that goes. Clean that up a bit, 5 times 2x is 10x, x squared plus 1, so the power of 4, and you're done. Here's the next example, differentiate 7 outside of 3x minus 1, all to the power of 5. So once again, power down, so it's going to be 7 times 5 this time. 3x take away 1, the power minus 1, so it becomes 4, and then multiply by the derivative of what's inside the bracket, which is 3. And you should get 7 times 5 is 35. 35 times 3, I think, is 105. 3x minus 1, all to the power of 4. Done. Okay, the next one, y is equal to 2 y is equal to 2 minus 5x cubed, all to the power of 4. So power down, 4, bracket, 2, take away 5x cubed, power minus 1, multiply by the derivative of the inside. So that's going to be minus 15x squared. Clean that up a bit. So 4 times 15 is 60x squared. Outside 2 minus 5x cubed, all cubed. Okay, so what happens when you have a negative power? Well, same process. You still bring the minus 3 down. But this time when you subtract 1, it's just going to go more negative. So it's the power of minus 4. And then I multiply it by the derivative of the inside, which is going to be just 7. So y dash will be minus 21, 7x minus 4, all to the power of negative 4. Now you could write it like this with a negative power on the bottom. That's also totally okay. Okay, so what happens when you have a surd or a root, as we can see here? Well, we need to convert that so that it's got an indice. So the square root is actually a half. And then now we can differentiate. So y dash is going to be 1/2, 5 minus x squared. A half minus 1 is minus a half. And I multiply by the derivative of the inside, which will be just being minus 2x. Now a half times 2 is minus 1. And then stick the x on, I'm going to have minus x. And then this bit here, okay, so this bit here has a negative power, which means it's going to be the reciprocal. So that's going to be times 1 over 5 minus x squared. And the half power is a root. So the half power is a square root. Bring that all together. That's your final answer. Okay, so when your root is in the denominator, we want to try and bring it back up to the numerator using our indices. So what I'm going to do is I'm just going to leave this 1/3 out the front here. And I'm just going to convert the root. So I'm going to have 3 minus x cubed in the numerator. And because it's a reciprocal, so I'm putting it to the top, make it negative, and the power is going to be a half like that because it's a square root. So now I differentiate. Let's just do dy dx this time. So I bring the power down. So I'm going to have 1/3 times minus a half outside of 3 minus x cubed. Now it's minus a half take away 1. So I'm going to have minus 1.5 or minus 3 on 2. Times by the derivative of the inside, which is going to be minus 3x squared. Okay, so what do I have? Well, I have 1/3 here and I have minus 3 there. So that's going to be just minus 1. And then minus 1 times minus a half is just going to be a half. So I'm going to have x squared over 2 left over. Outside of 3 minus x cubed, all to the power of minus 3 on 2. And I can leave it like that, or I could once again put the root on the bottom so that it's like this. So the 2 here tells me it's a square root, so it's 3 minus x cubed. And the 3 in the numerator tells me it's the power of 3. And then you are done. Alright, that's it for today. If you enjoyed this video, like it. And if you want more videos like this, subscribe and let me know in the comments what you want to see. But thanks for watching, and I'll see you in the next one.